first is scientific importance, which includes various reasons for conducting experiments. Some examples are to test hypotheses, for the sake of inquiry, to try out a new method or technique, to establish the existence of a behavioral phenomenon, and experiments to explore the conditions under which a phenomenon occurs. The second and third are reliability and generality, respectively. Reliability, as defined by Sidman, is, quote, will the experiment, if repeated, yield the same results, end quote. Reliability is presented in terms of statistical manipulations of data, with chance as the enemy. Data must be proven to have a low probability of belonging to chance, and with some trepidation we accept such data into the fold. Sidman pokes fun at the science of chance, as exemplified by the following. But there exists a science of chance, and who ever heard of a science whose subject matter is unpredictable? The reliability Sidman speaks of is more commonly known as the reliability coefficient, and was born from inferential statistics. To the credit of Cronbach and others who developed the reliability coefficient, Sidman slightly misrepresents their intentions and does not appreciate fully the context under which the coefficient was developed. Cronbach and his colleagues were interested in the psychometrics of testing instruments, such as their test-retest reliability, split-half reliabilities, and others. See section in this manuscript on different types of validity and reliability. In other words, more of an internal consistency of the test instrument. The more typical use of reliability in psychology refers to a test or other instrument's ability to yield approximately the same score across different occasions. Although not without similarities, this is quite different from reliability conceptualized as an experiment, if repeated, yielding the same results. In addition, it should be noted that this conceptualization of reliability for both Sidman and Cronbach can be traced to the assumptions of classical test theory. Cronbach and many others recognize the limitations of reliability, statistical methods, and the like. For example, quote, one of the important contributions generalizability theory makes is its strong reminder to us that a test's reliability is not something that statistically resides within the test. The reliability of a test is very much a function of the circumstances under which the test is developed, administered, and interpreted, end quote. Critical to the accurate interpretation of a test score is an understanding of each of the individual sources of variance, or facets, that contribute to the test score. The new topic is generality. Thank you. If experimental findings are applied under circumstances that are somewhat different, will the same kind of effects be obtained? Types of circumstances include different forms of a test, different populations, different occasions, etc. For example, testing the generality of methods across different populations is commonplace. Some examples of different types of generality include subject generality. How representative is the finding for other organisms of the same species? Sidman argues that, quote, we cannot dispose of the problem of subject generality by employing large groups of subjects and using statistical measures, such as the mean and variance of the groups. It is not true that the larger the group, the greater is the generality of the data. Subject generality is an actuarial problem to which the currently prevalent statistical design is not applicable, end quote. Generality of variables. This type of generality has to do with determining whether a given variable or class of variable is relevant outside the confines of a particular experiment. Intermittent reinforcement is offered as an example, in that it has, quote, wide generality with respect to its effect upon resistance to extinction, end quote. Another type of generality is methodological. The generality of experimental techniques from one species to another. This type of generality most often involves a behavioral control technique, whereby its generality across species, settings, etc. is tested. Summary. Generalizability theory is an important consideration in the testing and measurement of an individual's or group's behavior, knowledge, skill, or aptitude. The statistical and mathematical processes involved may not be as important as some of the theory's basic assumptions. Variability in measurement is an issue that educators and behavior analysts will continue to grapple with long into the scientific future. The ability to investigate and perhaps more importantly to appreciate the complexity of the various sources of error and their interactions that can influence a particular measurement's reliability and generality can only improve our ability to interpret and analyze data in accord with our definitions of scientific importance and the questions we pose and then try and answer as educators and behavior analysts. I'll close with a final thought. Educators all over the country are being asked to define their universes, and those that have not taken the initiative are experiencing a frightening reality. Their universe gets defined for them. I offer a challenge to all educators and behavior analysts to carefully consider your definition and measurement of your universe, as these are the best tools for finding out what you really know. Thank you.